Good evening, friends. Today we will study about anticoagulants which are used in medical laboratories. I will give a complete explanation of the anticoagulants which are used in medical laboratory. Okay, so I will start this session with great enthusiasm, and I uh, I wish you will get a S on anticoagulants after the end of this session. So first, what are anticoagulants? First we have to know about different types of anticoagulants which are used in the medical laboratory, and it will be a comprehensive guide for the blood collection tubes, their mechanisms, and their applications in clinical diagnostic. Okay, so I wish it will be a great session for you and you will enjoy this session to the fullest. So let me start about anticoagulants. So before starting about the anticoagulants, we should know what is a anticoagulant. So what is a anticoagulant? So anticoagulants are substances which helps in prevention of clotting, which helps in the prevention of clotting of blood. When we take out the whole blood from our body, the anticoagulants help in the prevention of clotting of blood. Therefore, it also allows us to perform the test the uh, the test which are performed in the medical laboratory. So what is anticoagulant? Anticoagulant is a substance which helps in the prevention of clotting of blood because because some test in the laboratory requires plasma, and if the blood undergoes clotting, we will be unable to extract plasma from it. So some of the tests in the laboratory requires anticoagulants. So we can say that anticoagulant is a substance which helps us to prevent clotting of blood. Therefore, what are the roles of anticoagulants in a medical laboratory? Roles of anticoagulants are: it helps in prevention of clotting, so it interrupts the natural coagulation cascade, which helps the blood to remain in its liquid state for analysis. Now, there are some specific anticoagulants which now there are some specific anticoagulants which helps us to study the, now there are some specific anticoagulants in which when blood are kept it helps us to study the precise morphology of red blood cells, white blood cells and platelets. Anticoagulants also help in cellular preservation so that we can study the morphology of red blood cell, white blood cell and platelets. Now anticoagulants also help in chemical stabilization. They prevent the degradation of unstable analytes like glucose prior to centrifugation and testing. Now, when we keep the anticoagulant in the gray tube, it helps gray tube. If we keep the anticoagulant in a gray tube, it helps in the preservation of sugar in the whole blood because it contains sodium fluoride. So, sodium fluoride is an antiglycotic substance, that is, it does not allow the blood to undergo glycolysis. So, it preserves the sugar in the whole blood, and after centrifugation we can obtain the plasma from it, which in turn help in the test of glucose. And the most important function or the role of anticoagulant is it helps in diagnostic accuracy. So choosing the correct tube is the most crucial step in preventing pre-analytical errors. So if we want to do coagulation test, then we have to take the whole blood in the citrate tube, which is blue in color, which has a blue top. If we want to do any coagulation test, then we have to take the whole blood in the light tube, light blue tube, and it contains sodium citrate. For that, in that case, we cannot take the blood in any other tubes because each and every color of the tube is different for different types of test. So, for diagnostic accuracy, the correct tube, the choosing of correct tube is the most critical step to prevent the pre-analytical errors. And if we take the whole blood in incorrect tube, then it will also give false result of patient's report. Now I will move in the next slide. Now we will study about the mechanism of the anticoagulants which helps in us in different ways. Now the mechanism of actions. So when we are collecting the blood in the EDTA or citrate tube, then the EDTA helps us The EDTA and citrate tube helps in chelating calcium ions because calcium is a very essential element which helps in coagulation of blood. But EDTA is an anticoagulant in nature, so it removes the calcium from plasma, therefore ensuring us that no coagulation of blood will take place and we can perform our test in a perfect way. The second mechanism of action of anticoagulant is it helps in enzyme inhibition. It directly inhibits specific enzymes in the clotting cascade such as thrombin and factor 10A by accelerating antithrombin, and it is done by heparin. Heparin is a naturally collected anticoagulant. Why it is naturally collected anticoagulant? Because it is present in our liver. Heparin is a natural anticoagulant because it is present in our liver. Now the third mechanism of action is anticoagulants are antiglycotic in nature, that is it inhibits the enzyme enulase which completely stops the breakdown of glucose in our blood cell post collection, and it is in the sodium fluoride tube which is grey in color. So when we collect the whole blood in grey top tube, then we can perform sugar test. Now I will jump in the next slide. So now I will come in different types of tubes which are used in biochemistry lab, in medical lab, not in biochemistry lab but in medical lab. Now we will learn about EDTA tube. EDTA stands for ethylene EDTA stands for I will change the color of the pen. EDTA stands for ethylene diamine tetraacetate acid, which helps in chelating of calcium ion, and it also helps in effectively halting the coagulation cascade, that is it prevents coagulation by chelating the calcium ion. It prevents prevents it prevents the coagulation of blood by chelating the calcium ion. It halts the coagulation cascade by chelating the calcium ion because calcium is the most important element in coagulation of blood. So it is an anticoagulant of choice for hematology because it preserves the cell morphology and prevent platelet clumping better than any other additive. It is also, if we collect blood in EDTA, then we can also perform experiments of hematology, and it also prevents the coagulation. It also preserves the cell morphology, which helps in the study of red blood cell, white blood cell, and platelets. And the primary test which we can do with EDTA is complete blood count test, blood smears, HbA1c, and blood typing. Now I will jump in the next slide, and the next slide contains the anticoagulant or tube named as light blue tube, which is known as sodium citrate. Now sodium citrate works by reversing binding with calcium ion in the plasma. Unlike EDTA, this process can be reversed in the lab by adding calcium back to the sample, because sodium citrate is an anticoagulant which is best used for coagulation test. So unlike EDTA, it helps in binding of calcium ion in the plasma. Therefore, citrate tubes requires exactly 9:1 ratio of blood to anticoagulant. Underfilling leads to prolonged inaccurate coagulation test. Sodium citrate tube are used in coagulation test, and the coagulation it is generally coagulation test includes prothrombin time, APTT, D-dimer, and fibrinogen test. So I will go in the next slide, which is heparin tube. Now heparin acts by accelerating the action of antithrombin, which subsequently neutralizes thrombin and prevent the formation of fibrin. Now heparin tube. Heparin tube is made up of heparin is made up of sodium heparin, lithium heparin tube consists of sodium heparin, lithium heparin, and ammonium heparin. It does not chelate calcium. It is also ideal for measuring the plasma electrolyte and various enzymes where calcium levels must remain undisturbed. Actually, heparin tube is mainly used for the action of antithrombin. That is, it prevents thrombin formation, and and if we keep the whole blood in this tube, we cannot extract serum from it. It is only used for plasma testing. The primary test which we can do is using heparin tube is comprehensive metabolic panel test, cardiac troponin, and stat chemistry test. So I will go in the next slide, which is sodium fluoride tube. Now sodium fluoride tube are gray top tube. They are gray top tube which contains two additives. One is potassium oxalate, which is an anticoagulant that precipitates calcium, and sodium fluoride. Sodium fluoride acts as an anticoagulant agent. Without it, blood cell would consume the glucose in the sample. So sodium chloride is a very important anticoagulant agent. That is, it prevents glycolysis in the blood. But without sodium fluoride, the blood will consume glucose in the sample. Therefore, it will falsely lower the test result by about 5 to 7% per hour. The main tests which are used by using sodium fluoride tubes are fasting blood glucose, lactic acid, and blood alcohol test. So I will jump with the next slide. So here are some pre-analytical variables which we have to be very much careful while storing the blood in the anticoagulant. So we may face some pre-analytical errors like clotted sample, clotted sample. The clotted samples are formed if we take inadequate amount of blood. It is caused by inadequate mixing. Means not inadequate amount of blood, but it is caused by inadequate mixing of blood. So when we collect blood in any of the tubes, then we have to mix the blood in that tube by simply rolling or centrifugation, or else it will cause clotted sample. Okay, all anticoagulant tube must be gently inverted 5 to 8 times immediately after calculation. Means we have to take the tube and we have to roll it 5 to 8 times post collection of blood. The quantity not sufficient. Now, if we fail to fill the tube up to the designated volume mark, means if we do not sufficiently fill the tube after if we fail to if we fail to take blood or any other sample in not a sufficient manner, then it will be very much detrimental in coagulation testing. So when we are taking the sample in sodium citrate tube, we should fill the tube in sufficient quantity. Now, hemolysis. Hemolysis means rupturing of red blood cells, means destruction of RBC. And if hemolysis occurs, then it releases intracellular potassium and enzymes into the plasma. Therefore, it may alter clinical results. And the last one is additive contamination. Now, what is the meaning of contamination? If we contaminate something, that is any bacteria or virus or any pathogenic substances while we are collecting the blood, then it may cause false result. Okay. Now we will study about order of draw. The order of draw is given below. First, we have to collect the blood in yellow top tube which contains SPS, and it is used in medical microbiology lab for blood culture. Then we have to collect blood in light blue top which contains sodium citrate and it is used in coagulation test. Then we have to collect it red or gold, which is a clot activator. Red tube is a red red tube is also known as clot activator tube, and it is used in clinical chemistry, that is biochemical chemistry and serology labs. Then we have to collect blood in green tube, which is heparin, and it is used in clinical labs to perform stat examination. Then we have to collect blood in lavender or EDTA tube, which is used in hematology or blood bank. Hematology means it is used in complete blood count and hematology lab because it preserves the morphology of the cells. And then we have to collect the tube in gray tube, which is a sodium fluoride or oxalate tube, and it is used in determination of glucose and lactate in this cell. So thank you friends for giving me a patient sharing. If you like my video, then please like and subscribe. Thank you so much for giving me a chance to speak in this live session. Thank you.